differences first. So in this case, we want to see the difference. For example, you want to see, is there any difference for the level of this one, btotal.cat is the level of awareness kan? We want to see the level of awareness between different age groups. Okay? So how to do that is very simple. You can just click the analyze, descriptive, and proceed with the crosstab. Crosstab lah. Crosstab. Okay, I make a repetition. You go here, analyze, descriptive, and the crosstab. Crosstab is for the chi-square lah. Not chi-square sahaja. It's for anything to do with the cross-tabbing. Cross-tabbing means that crosstab ni adalah istilah bermaksud ni apa ni? Crosstab lah, crosstab. Kita ada X, kita ada Y. Ni namanya crosstab. Crosstab apa dalam bahasa Melayu ah? Crosstab ah, titik bukan persilangan. Crosstab. What is the crosstab ah, ladies and gentlemen? Can anybody help me ah? Bukan titik bersilang. Crosstab. Apa nama dia? Astagfirullahalazim. Allahumma salli ala sayyidina Muhammad. Crosstab. What is the crosstab ah? Cross tabulasi. Tabulasi silang. Gila. Cross tabulation, tabulasi silang. No. That is the tabulation that we want to speak up. That is the tabulation that we want to estimate, and that is what we want to know. For example, just now we have the age. The age is our factor. So less than 30, more than 30. And then we got two different category, right? For the level of awareness. High level, low level. So we want to put the number here. And then we want to know whether there is a different or there is no different in terms of the proportions of the people that being tabulated inside this table. So this is what we call as a cross-tabbing. You understand or not? No. Okay, I make a repetition again. We got something to do with this cross-tabulation. Jadual tabulasi silang. So we got here as a X and then this Y. Ni age kan less than 30. This one is age more than 30. And then we got higher knowledge, higher level of awareness, lower level of awareness. So we got number here, right? Maknanya orang yang kurang umurnya 30 dan level of awareness the high. How many? So this one how many? How many? So this how many is going to be computed as a proportion, and therefore we want to know whether there is a similarities or there is no similarities. That's all in terms of their profession, in terms of their proportion. Pardon? For this lah. You want me to conduct it using manual or computerized? Okay, computerized will be explained now. Okay, to do that is very simple. Yes, correct. Okay, to make you clearer, okay, I give you this idea lah. You got already your number of sample is 26, correct? So now you got people who got those more than 30 and less than 30 years old. Understand already kan? This is your IV lah. And then you got your DV lah. Your DV is more than 7 more than 7, which is the high lah. High or low. High or low level of awareness. Okay, this one also got number, right? This one also got number. Correct or not? So now we want to know the distribution. Is the distribution is the same or not? By combining these two factors, not looking into single one. If you looking into single one, you are looking into like this, you know. For example, I put here h.cat. I put here is btotal.cat. So this one is looking into a single one only. For example, less than 30, 16. So how many less than 30? That is low level. How many less than 30? That is high level. Yes, these two boxes I need to be combining. That's why we call it as a cross tabulation. Cross tabulation means that is a cross. What is a cross? Bersilang. Bersilang ke apa benda lantak ke orang lah. That is the idea. Okay, so that is the concept. That is the concept. Because just now I'm giving you the explanation for the simpler one. You know simpler one or not? The simpler one is actually being simulated as follows lah kan. You got two column. The first one, high level of knowledge, how many? Low level of knowledge, how many? So you want to make a comparison between these two column. So you have the assumption first lah, the column are similar, the proportion are similar, 50-50. So you want to see the beza between the observed minus the expected, the power of 2 divided by the expected, and then you find the sum, and you find the chi-value, and then you're looking into the distributions of the chi-value, whether it's fall or not fall within our area under curve, and then you make a judgment whether you want to reject or fail to reject our null hypothesis. That is for us, for me, to calculate. But for you to understand, you just want to know whether these two variable, which is this one is the IV and this one is the DV, different or not different, that's all. By looking into their p-value. Don't ask me so many things about how they are doing. That is their job, you know, because there is a computer. Let him or her do their job. I mean, the computer do their job lah. But we must know that the idea is that one is a crosstab. Because the crosstab here, if you say that the crosstab is only for chi-square, it's not fair. Because the crosstab also can use for many other things. You want to calculate for the risk, you want to calculate for the kappa statistic, you want to do the Kendall tau B, you want to do the pi and Kramer's V, you want to do the correlation. All of this also can be utilizing the crosstab. To make your life easier, you must understand crosstab is about two tables and then you want to make it cross. That is crosstab. Yes, you want to combining two factors together and then see is there different or not different. That's all. The different, we are talking about the proportion of the differences. Okay, so how we want to do that is very simple. The first of all, see, I also do not forget, my pen also terbalik upside down already. So now we are going to establish our null and alternative hypothesis. What is our null? The distributions of the people, distributions of the group of H are similar with the equal proportion with the awareness group lah, awareness group. Same also this one. Distributions of the group of H is not similar with the awareness group because we are talking about the distributions of the group. Okay, so now we are going to run it. How to run? Analyze, descriptive, and across a tab. So now you see the column here. Usually the column we set for DV. DV we put inside column. Usually means that what? Sometimes not sometimes Selalunya lah. Okay, and then the next one you put your factor inside the row. What kind of factor that you are talking about? I am going to talk about the H. So the H I put here inside the row. So I got row, I got the column. Row is our factor, column is our DV lah kan, DV. So now you are going to click the statistic button. Click the statistic button, request for the chi-square. And then continue, correct. And then the next one you select the cell. Click mana? Okay, again. Analyze, descriptive, crosstab. The first one, put your DV. Put your DV is the B total.cat inside the column. And then put your IV H.cat inside the rows. And then go to the statistic radio button, click that one. And request for the chi-square. Go to the clicking continue button. And then next, click the cells radio button. So you can click and request any of these. But usually for me, I only interested to select the column. The percentage of the column. And also perhaps I want to see the expected count. And then I'm going to click the continue. And then I'm going to click the OK. After you click the OK button, this kind of table are being produced for you. Can you see it or you cannot see it? Can you see it or not? You can see it already. This is your count. This is your count. This is your expected count. This is your expected count. And then this count are going to use this kind of formula, you know. Observe minus expected, the power of 2 divided by the expected, and then you sum it up, and then you got the chi value. So the chi value indicate here is very small. So now when we want to look at, we need to look at the Pearson Chi-Square. You see the Pearson Chi-Square show A here. So we refer to the A, they indicate 0 cells. That means none of these are expected count less than 5. So that means what? We can proceed with our chi-square. Excuse me. So after you proceed with the chi-square, what is your chi value? Your chi value is P less than 0.001. This is your chi value. What about your p value? P value, where to find? This one lah. This one. Assumption significance, your p value is p is equal to what? P is equal to 1.000, correct? More than or less than alpha? More than, correct. More than alpha, reject or fail to reject null hypothesis. Are you sure?
Yeah.
Yeah, correct. More than fail to reject null hypothesis. And then what is your conclusion? There is no significant difference of the distributions of the different age category and also the different awareness levels. That means if you are less than 30 or you more than 30, you will have the similar perception. You see, this one is so perfect, you know. When you are less than 30, you are low, this number. When you are more than 30, you are this number. So that means you having no trouble in terms of perceive the level. Okay, understand or not understand, ladies and gentlemen? The hypothesis. Your null will be what? There is no significant difference between the proportions of those who are categorized under the salary with those who are categorized under the B total cat, which is your level of awareness on lung cancer. And then the next one, you go to analyze and go to the descriptive statistic and click the Crosstab. Reset first, reset, and then please put your what? This one is what? DV. Your DV is B total.cat, and then please choose your salary.cat. So this one we will conduct the 3x2 table. Just now we conduct 2x2 table. You understand or not? Because salary got 3 group, 3 group. Less than 2,950, 2,950, and more than 3,300 lah, something like that lah. I can't remember at all lah. And then go to statistic radio button, click for chi-square, continue, and then click the cell, and then request for the percentage in the column. And then go to the count, click for the expected. Cells, you can request everything inside this box lah actually. But if you want, you can only focusing on the column, okay? And after that, you can just hit the OK button, and then it's going to produce some table like this, you know. Okay, so this one we can see some sort of more beautiful kind of data, you see. So let us interpret together about this data. The first one you can see here, this is about the salary of the categorical data. And then this is about the level of awareness. Okay, can you see this table? Is this table being produced inside your computer? Or your computer hang already? God, okay, that's good. So now we are going to look into the Pearson Chi-Square. You can see that the level and the value of the Pearson Chi-Square is equal to 2.400. Correct or not? Yeah. Unfortunately, under the A, you see the A here? You look down here, 2 cells, 33.3 have expected count less than 5. What does that mean? That means our Pearson Chi-Square is violated. And therefore, we cannot use the Pearson Chi-Square values. And therefore, perhaps you can use and proceed with the likelihood ratio. So yeah, your likelihood ratio will be 3.175, and then your p-value is equal to 0.204. It is more or less than alpha. Reject or fail to reject null hypothesis. Fail to reject null hypothesis. Therefore, you make a conclusion there is no significant difference of the distribution of the proportion for the salary group and also for those who are having the level of awareness group. That's all. Thank you very much. Settle. Peher o peher ni? Inshallah ta'ala alayya fi hazal yawm. Okay? So this one is the second example. So you can do it when you go back home lah. So this one are using the probability statistic. You know probability statistic is equal to 1 lah. So if you add all these things, become to 1 lah. Become 1 1, and then it's been divided into yes, no, don't care. So actually yes, no, don't care ni probability statistic ni they are expected. You know expected count. So you have the observed count and then you have the expected count. This one usually I encourage students to calculate manually. But never mind, you can skip this one. If you want to do, we do it later on. Okay, the next one we are going to learn about the chi-square test of the independence. This is the simplest one to measure the risk factor and the association with the DV. The risk factor is what? The risk factor is the factor of your demography lah. Because you are talking about the demography risk factor kan. Overview about the next one is the chi-square test of the independence. Test of the independence is actually for you to understand and analyze your association. Association ni macam pengaruh lah. Pengaruh, or we call it as influential factors between the IV and DV. So you must have two variables, which is your IV and DV lah, must be in categorical form. We are using the same thing, which is the chi value, but we added one more measures of association here. The only difference is we click or tick this kind of statistical element. How to find this one is available in your data analysis package. Don't worry, I'm going to teach you how to obtain this one. And then we are going to calculate. If you want to calculate manually, you can calculate using this kind of formula. And then the hypothesis as follows. The hypothesis is very simple. For example, you want to investigate and you want to know the significant association of the certain DV towards IV. In our case just now, for example, we want to know, is there any significant association between the DV, which is the higher level of awareness or low level awareness, with the gender. For example lah, with gender. Ada tak significant antara knowledge dengan gender ni? Data dua-dua categorical. So what kind of analysis that you can do? Chi-square only. And the chi-square of that, of what? Chi-square testing for the independence. So our null will be DV is independent to IV. That means DV is what? DV is the level of awareness. Level of awareness is independent, is tidak bersandar with our IV is what? Gender. Why? Because this is the only categorical data. We cannot use correlation between the numeric data of the DV and the gender, because the gender is always nominal. We cannot change that facts. Okay. So what is our alternative hypothesis? DV is dependent on IV. DV level of awareness dependent, bersandar, kebersandaraan, kebergantungan, keberpengaruhan, whatsoever that you want to think of lah with your gender. Gender is what? Gentina, correct. The next one is the significant level. Jumhur ulama suggest that alpha is equal to 0.05. And then we run and report the statistical values. Okay, the next one, we make a decision either you want to reject or fail to reject, is similarly the same. It's same and kind of macam nak sama dengan correlation, which is if we reject the null hypothesis, there is correlation. If we fail to reject the null hypothesis, there is no correlation. Same also goes to this one. If you reject the null hypothesis, DV dependent to IV. If you fail to reject, DV independent to IV. Independence means that not bersandar, not influences, not correlated, not associated, not. Okay. So now we are going to run the data. Okay. So let us look into the example here. Okay. I give you one simple example. If you can see here, a study was conducted to test a relationship. A relationship between a student group. Student group of what? Student who are staying inside the campus or student who are PJJ. You all are kan? You all are most of you are PJJ or campus student lah kan? And then academic performance. Academic performance high, moderate or low. This is only the data. So now test the hypothesis on the relationship between the two variables at a significant level of 0.05 and then calculate and describe the appropriate measures for the association between the two types of variables. So how we want to enter the data is very simple, okay? I'm going to share with you and show to you directly lah. Otherwise, you cannot do it also lah. Okay. So just open the new tab here. So now I'm going to ask you a question. How many variables that you can find in this particular example? How many variables that you can think of? Very good. The first variable is what? Group lah, group of the student. The group of the student who stay inside the campus or PJJ. Very good. You all are very good. And then the second one will be what? Acad. Very good. Academic performance. So usually I will put here 3 as high and then 2 is moderate. Okay, moderate, and then 1 is low. Okay, and then finish. But This one is a total number. So when total number, we are going to use the weight cases. So if we want to use the weight cases, we must request for frac. You know frac? Frac is what? Wow, very good. It's correct. It's a frequency. So this one is scale. The other one will be the nominal data. Okay, now our data are already being set up, and then we are going to key in our data. Can we key in together? Can. Okay, the first one is the first group. The first group is those who are the campus group. Okay, the first one, staying in campus, academic performance high. How many makhluk?
93.
Correct, 93. The second one, the students stay in the campus, the academic is moderate. How many people? Oh, sorry. Stay in the academic, moderate academic is 70. The next one, stay in the campus, low academic, how many? 12. The next one, stay outside the campus, academic high, how many? 87. Stay in the outside, academic moderate, how many? 32. Stay in the outside, academic so not good, how many? 6. Finish. Key in already. Not key in. Please listen to this one because this is the last version of the explanation for the chi-square. Okay, now we got the idea. We want to measure the influential factor of the group and academic performance based on the raw data that we have from academic division. For example lah, we got kita panggil budak-budak duduk kampus ni. Mana duduk kampus? Okay, ramailah yang duduk kampus ni kan. 93 campur 70 campur 12. We collect all those campus student ni and then we ask them who got 3.0 misal kata kan. So semua pun angkat tangan. So kita kira-kira 93. Who got 2.5 until 3? Okay, 70 orang. Who got less than 2.5? Contoh 12 orang. Okay, then we know this is all the campus punya students. And then we invite those yang PJJ. Kita invite masa bila pun tak tahu sebab dia PJJ susah. PJJ ni maksudnya perjalanan jarak jauh. Mana sangat jauh, nak cari pun tak jumpa. So we manage to call them, we ask them, okay, are you PJJ student? Yes. Okay. Your academic performance high. Okay, kita kira-kira daripada call telefon tadi 87 orang high, 32 is the moderate and then 6 will be low. So now we are going to tabulate accordingly. So our hypothesis null will be there is no nak senang you buat yang macam saya ajar tadi. To make your life easier, you just make like this. DV is independent to IV. That means our academic performance is independent to group of students. And then what about our alternative hypothesis? Pandai. DV is dependent or academic performance is dependent to the group of students. Okay. And then we are going to analyze this data. How you want to analyze? Very simple. First one, you go to data first. You weight cases. You weight cases first. You put the weight cases under the frac. Okay, you do like this and then you hit the OK button. After you hit the OK button, is finished. The first step is finished. And then the next one, you do it already? No. Okay, I made a repetition. You go to the data and go to the weight cases. Go to the weight cases by, and then please insert the frequency inside the frequency variable and then hit the OK button. After you hit the OK button, the output are going to say by, like this, weight by frac. Okay, and then finish already the first step. And then the second step will be like this, analyze, descriptive, and Crosstab. Same also like before. We are going to use the Crosstab. Same like before, okay? And then you understand already, right? The column must be your DV or IV? DV. So our DV is academic performance and our IV is our group of students. Okay. Just put inside the data there. Can you follow? You cannot follow. Okay, never mind. I make a repetition. First, data, weight cases. You weight cases. It happen to be like this, and then you must go to the analysis. And then go to analyze, descriptive, and Crosstab. So Crosstab is similar like before. You put your DV inside the column and then you put your IV inside the row. And then you request the same thing except this one you tick also these two fishes. These two things lah. which is the first one is contingency coefficient, and then the next one is the pi and Cramer's rate. Only additionally you pick these two. Why? Because this one is the itemized statistic to measure the association. For measuring the association. This is why we need to do the second one, because we want to do the measuring association. We want to measure the strength, direction, and also whether there is association or not. Yang first tadi, we do not request this one because we want to know that is different or not different. Yes, yang this one we want to know about the different and also associate or not associate. Yes, correct. But you cannot do like this lah. Why you cannot do like this? Because you need to know your frequency and distribution, and therefore you need to ask for the chi-square. After that, you click continue, cells. You can click this one. You do not want to click also can, but this one you put lah because you want to establish the output based on the percentage of the result. And then after that, you click continue. And then you click OK button. It will come out something like this. Okay. The first one, I want to tell a story. This one, same like before. This one, same like before only. The difference is you add one more table down here. Understand or not understand? Okay, the first step. We need to look into the cell. Expected count less than 5. So far so good because everything is below 20%. And therefore, the Pearson Chi-Square can be used. And then we see the value of the chi is equal to 8.253. And then our p-value is 0.016. This one is less than or more than alpha. More than alpha, reject or fail to reject the null hypothesis. Fail to reject or reject reject. Your rejection of the null hypothesis. After you reject your null, then you will say that there is a significant association on the DV to IV. Or nak senang yang ini you akan cakap apa tau? DV is dependent to IV. And then before this you already learn about correlation. You know about the R value got strength and direction, right? This one is the pseudo R. Pseudo tahu apa pseudo? Dia tak macam R sangat tapi macam-macam nak macam. Macam tu. Jangan macam-macam lah kau ni. Macam tu lah orang kata. So this one is around 0.2. 0.2 consider low lah kan. So that means that is association but it's not so strong. This is the value of the association. Okay. So far so good, understood? So if you run and then obtain these three table, don't say different but say association. That is an association between the IV and DV. Or you want to say DV is dependent to IV. Boleh, tapi jangan tulis DV dependent to IV. Itu macam awak suruh saya tuliskan untuk tempat kosong tau. You must put the complete words. Academic performance is depending to, yes, the group of student, and it is significant at a point level of 0.05 where the values of the chi-square is equal to nak bagi panjang supaya tebal tesis korang tak nak. Tak nak, tak tebal, nanti buat balik semula. Okay, that is how we want to run this thing. Okay. After you finish, then we run our data and then finish already. So our data also the same thing, but this one no need to put the data and wait. Let's say this one I want to investigate the btotal.cat with the what tadi saya cakap? Gender. So now go to analyze straight away, go to the descriptive statistic and click across a tab. After that, you are going to click the btotal.cat inside the column. And then also put the gender inside the row because that is our factor. You want to put everything inside also to run simultaneously, also up to you. But in this case, I'm going to be only put one IV, which is the gender. And then go to the statistic, tick for chi-square contingency coefficient, and then click continue. And then after that, go to the cell and then click for the column and continue also. And then click OK button. OK button, it become like this. Okay, become like this. So this is our output for the male and female btotal.cat. So you can see here the two cell expected count less than 5 is violated, and then therefore we can use the Fisher exact. Okay, Fisher exact senang cerita memang tidak ada association lah. Because if you see the Fisher exact, utamakan Fisher exact as the second option after the Pearson Chi-Square.